Okay, in this lecture we are going to see some very easy example in order to compute determinants, and in this case we can start considering a very simple 2 by 2 matrix, for instance 1 minus 2 1 4. We want to compute the determinant of this matrix. We can apply, if we call this matrix A, determinant of matrix A, when we consider just a 2 by 2 matrix, we can apply the formula A11 A22 minus A12 A21, which means to consider the product of the elements along the main diagonal minus the product of the element on the second diagonal. So in this case we have determinant of A equal to A11, which is 1, times A22, which is 4, minus A12, which is minus 2, times A21, which is equal to 1. So the final results will be 6. Now we consider a matrix a more complex matrix, and we can apply the Laplace expansion. So we have 0, 1, 0, 0, 2, 3, 1, 0, 4, 2, 1, 1, 1, 0, 2, 0. This is a 4 by 4 matrix, and we want to compute the determinant of this matrix. In order to apply the Laplace expansion, it's easy to understand that it's better to consider the first row. Why we consider the first row? Because we know that if we take under consideration the first row, the determinant of A can be computed as A11 times the cofactor so times the cofactor C11 plus the second element of the first row, which is A12 times the cofactor C12 plus A13 times the cofactor C13 plus finally the element I14 times the cofactor C14. I hope you can write, no, it's not clear, so I can write again. So this is equal to A11 times the cofactor C11 plus A12 times the cofactor C12 plus A13 times the cofactor C13 plus A14 times the cofactor C14. In this case, more elements of the first row are equal to 0, so this is equal to 0 times the cofactor C11 plus 1 times the cofactor C12 plus 0 again times the cofactor C13 plus 0 again times the cofactor C14. So this is equal to the cofactor C12. The cofactor C12 is equal to minus 1 times 1 plus 2, so the row, the sum between the row and the column of the elements we are considering, times the determinant of the minors M12. What is the minor M12? Is the matrix or the submatrix we can obtain by deleting the row and the column of the element we are considering. So in our case we can write again the matrix A as 0, 1, 0, 0, 2, 3, 1, 2, 3, 1, 0, 4, 2, 4, 2, 1, 1, 1, 0, 2, 0 is our original matrix. We are considering the element C, the element A12, so this element. The minus M12 is the submatrix we can get deleting the row and the column of the element we are considering. So we can write that the determinant of the minor 1, 2 is equal to what? Is equal to the determinant of the matrix 2, 1, 0, 4, 1, 1, 1, 2, 0. So we need to compute this determinant. Again, we can choose the last column in order to apply the Laplace expansion for computing the determinant. We can choose this element, which is the only one other than 0, and we can compute this determinant using the last column, the third column. So in this case we have determinant of M12 equal to 1, which multiply the minors of this element. But the minor of these elements is a 2 by 2 matrix we can get deleting the row and the column of this element. So we have the determinant 2, 1, 1, 2, but we need to consider also the position of this element. So we have to multiply by minus 1 to the power of the row and the column of this element. So second row, third column, 2 plus 3. So this is equal to minus 1, because we have minus 2 to the power of 5, times the determinant of this matrix, applying the rule we have seen before. This is equal to 2 by 2, 2 times 2 minus 1. So finally we get minus 3. But we want to compute the determinant of our original matrix, which is equal, we know the determinant of A is equal to the cofactor C12, and the cofactor C12 is equal to minus 1 to the power of 3 times the minor 1 M12. So it's equal to minus 1, because minus 1 to the power of 3 is minus 1, times minus 3. So finally, the determinant of our matrix A is equal to 3. I want to show some easy properties of determinants. First, if we consider matrix A, and the transpose of this matrix A, we can see that the determinant of matrix A is equal to the determinant of the transpose of this matrix A. What is the transpose of matrix A? Is a matrix we can get by changing row and column in a matrix. So for instance, if we consider 2 by 2 matrix, for instance, the determinant of matrix A, 2 by 2, whose general element is A11, A12, A21, A22, we know this determinant is equal to A11 times A22 minus A21 times A12. Now, the determinant of the transpose of this matrix is equal to the determinant. We need to change the first row becomes the first column, so A11, A12. The second row becomes the second column, so A21, A22. applying the rule in order to compute the determinant, we have A11, A22, the elements along the main diagonal, minus A12, A21. So we have the same results, the same determinant in a matrix or in a transpose of this matrix. Another important property is that if we consider a 2 by 2 matrix, but it's true also for matrix of greater order, in this case we can, if we substitute, we consider matrix which we have the second row, A1, A21, A12, A22, and the first row is equal to a scalar multiplied by the second row. So we have key A21, key A22. In this case, the determinant will be equal to Ka to 1, A to 2, minus K, A to 1, A to 2, applying the rule of consider the main, the second diagonal, and this is equal to 0. It's very important because when we use matrix in order to solve system, we'll see that if also in matrix form, the first row is a linear combination, of second row, but we get the same results if we consider the column. In this case, determinant is equal to 0. And this is very important in the following sense. If we have a general matrix A11, A12, A21, A22, the determinant of this matrix will be equal to the determinant of a matrix in which we can consider, for instance, the first row equal to the previous matrix A11, A12, and the second row equal to a linear combination of the first and the second row. So the second row is A21 plus a scalar K A11 and A22 plus a scalar K A12. We can compute this determinant. This is equal to, considering the main diagonal, A11 times A22 plus K A12 minus A12, considering the second diagonal, A12 which multiplies A21 plus K A11. This is equal to A11 A22 plus K A11 A12 minus A12 A21 minus K A11 A12. This and this give 0, and finally we get A11 A12 minus A12 A21, which is equal to the determinant of A. So our property is has been confirmed. We cannot read this part, so this A11 is A22. Okay, this is equal to the determinant of A.